Work it, make it, do it, make sense.
I'm Michał, I work at Ocado Technology in Kraków office, and this is a functional programming talk at functional programming in Java and Scala. And I will show you mostly Java code, but I will also want to compare Java and Scala side to side, so the same functionalities in both languages so that you can see the difference. And I will be honest, this is a talk about functional programming, but I don't want to show you any math. I don't want to explain why monad is a monoid in the category of endofunctors, and I don't want to convince you that functional programming is cool either. What I want to do is show you some practical, applicable examples of functional programming in Java so that you can use it whenever you see it fit. So imagine that you are part of a remote team. You are doing lots of contracts for different customers over the world, and one day a new client approaches you. He heard about this thing called Twitter that people on Earth use. He wants to have something like that in his galaxy. So what we do, of course, we happily accept, and we promise to have a working prototype by the end of the next week. Right away, we go to our favorite coffee house and start hacking. And the main functionality, the main requirement for the whole software is to show who follows whom, so the followers functionality. We spawn our IDE, and because we are in a coffee house, we want to do functional programming, right? So what does it mean to be a functional programmer in Java? The current state is that we want to have immutable collections, we want to create immutable types, we want to have pure functions, avoid reassignments, and of course, we want to have functions that take functions as parameters and return functions, so the higher order functions. And we can have those in Java, right? Because we have lambdas and streams. Am I right? Well, yes and no, because lambdas, of course, help a lot because they are functions as data, and the streams are also very okay because they bring the higher order functionality to the language. But the rest of the API hasn't changed after the Java 8 update. So we still have mutable collections, and we need to use something like Guava or other external library in order to have immutable collections. And in Scala, the same thing cannot be said about Scala. So everything is built into the language. We have val keyword, which is more concise. We have functions are first-class citizens, the real ones. And of course, we have immutable collections. So the API for higher order functions is a lot more concise. And in terms of basic functional programming, whenever you see my Scala code, the same thing can be done in Kotlin pretty much in a similar way. But I'll be showing Scala code, but bear in mind that the Kotlin alternative will be very similar. There are some differences at the more advanced levels of functional programming between those two languages, and I will touch upon one of those differences at the end of the talk. But I'm not here to talk you into Scala or Kotlin. I'm here to talk about functional programming, and we can have all those basic things that I just mentioned in Java today using a library called Waiver, which has just been renamed last month from JavaSlang because of trademark conflict with Java. So how many of you have used Java? Really, that's a real story. So how many of you have used JavaSlang or Waiver? Okay, cool. All my Java code today will be using Waiver, and I will explain all the things that are new, hopefully, as we go. So after including Waiver, we can have a more Scala Kotlin style in Java. So we can have immutable collections which are built in. We have functions which are built in. Those are functions that are compatible with the Java functions. Final keyword stays the same. And to create immutable types, we need to have still an external library or do them by hand. And the higher order functions look a bit better than with the stream library. So small disclaimer, I'm a Scala developer, and I was trying to do Java first time for a long time, and I picked Waiver very quickly. But if that's not the case for you, just please interrupt me. I'll try to explain as we go. So after including Waiver, we have almost everything we need in order to start the implementation. So let me show you how those things can be utilized in a real project. And the real project that we've been tasked with is Galactic Twitter and 1 week deadline. So let's model our domain first. We want to have citizens. We want to have citizens that have names. So every citizen in the galaxy needs to have a name. So this is abstract class, but we can have a concrete types. We can have a civilian with also just a name, a Jedi, a rebel, and a Sith, also just names. And of course, a stormtrooper, which is a type with a name, and a Boolean flag, which means whether this particular stormtrooper was cloned or not. So this is our domain model for the citizens of the galaxy. And we also know how to fetch those guys. So we know we have two methods, one for getting the citizen by providing just a name, and one for getting the followers for the particular citizen. And both of them are implemented by one of our colleagues on the other side of the globe, preferably in a coffee house. So both of those methods are returning futures. And those are futures from Waiver. Future models something that may be available in the future. Maybe because the computation that will return something in the future may also fail. That's why the future has two cases. So what can we do with such a type? This is the foundation for synchronous programming. What can we do with such a type? What do you think? So let's create a simple console application. We are backend developers, so we are trying to test our stuff with console applications. And some other colleague of ours will be doing the web application. So let's write a simple console application to find out. We first provide a name of the citizen that we want to get the followers for, and then we call our DB client. DB client gets citizen by name. It returns a future of the citizen, and then we, of course, go to our IDE, press dot on it, and see that there is a nice function called get, which gets the citizen out of future context. And we repeat the same procedure for the followers. So we are getting first the citizen, and then we get the followers for the citizen, and also get the followers out of the future context. And we are able to print the followers to the console. So we have done well, right? Yep. No? So what's the problem?
If get citizen by name fails, the line after will blow up.
Yeah, that's one of the problems. If it fails, then we have a problem. But the first problem probably that will appear in our happy path is that the user will just get stuck whenever the database is very slow, right? Because what future get does, it waits for the value to become available. So we wait for the value to become available in the user thread, in the thread that is getting stuff from the console and into the console for the user. So the user is waiting for something to happen without any feedback at all. And we should get users happy, right? By not blocking at all. Can we do that? So let's change our implementation and get rid of blocking. And this technique, this is a common pattern in functional programming, and that is we don't get the value out of the context. In this example, the context is future. We don't get the value out of the context until we really need it. So this is a common pattern. So all our transformations should be done inside the context because we don't know whether the value, for example, here is there or not, but we know what we want to do with it whenever it's there. So let's not unwrap the value from the future. Let's just map over it with the new line 111. Let's map it with the followers, get followers call to DB client. And what it does, you can see that on the top of the diagram, it will make the future contain another future, so future of future. That's why we need to flat map. That's why we need to use flat map. Sorry for this technical typo. Flat map, and then we'll get the future of list of citizens. So we're still in the context of future. That's why we use flat map. And we still are in the context of future. We just are getting the size of the list in order to get the count of the followers, the quantity of the followers. So as you see, there are no blocking calls at all. That's because our function also returns a future. So the pattern of mapping and flat mapping is so popular in functional programming that in Scala, we have a syntax just for it. It's called for comprehension. And both snippets on the slide are the same, so the Java and Scala code are totally equivalent. So in order to get flat map and map, we can just use this syntactic sugar. And it gets better whenever we have more of them. So what can we do with the function that returns future? Again, we can just transform it until we need the final value. But if we need the final value, we can just use another thread to process that value. And this is what for each function does. It's defined on future in Waver. For each in line 22, it takes a lambda. So we provide a function that needs to be called whenever the value becomes available in the future. We get the result, which is the list of citizens, and then which is int, that's a count of followers, and then we put it into the cached followers map. So a user will need to poll every now and then, but the call to this function won't be blocking. So we always return integer, and we in line 25, if there is no value in the cache, we just return 0. So that's the default value. And we used additional thing from Waver here because we didn't use the hash map from Java. We used hash map from Waver, and hash map from Waver is of course immutable. So every time you call a put, it returns a new hash map. Every time you call a get, it returns an option type. Whenever option is sum, that means that the value is there, and whenever it's none, that means the value isn't there. So this is how it works for the user. The thread is not blocking anymore, so that's cool. The value is cached. We get the real value after our third try. So we know that Darth Vader has 102 followers. So several threads are happening. No logs, no spawning the threads by hand. So that's the power of immutability and futures. And this was just a helper. This is just a helper application that we can use in order to test the backend service that we are implementing. But the real web application is also being implemented by one of our colleagues, as I said before. What he did is use the API, polled every 200 milliseconds, and backend is non-blocking, so the calls are very fast. Whenever the value becomes available on the server, it is returned and shown to the user. So everything works fine. But one night, the telephone starts ringing. It's our user. And he's not happy. So he files a bug report. And he said that he has zero followers. And it's not possible. So what we do, we run to our desk, fire up the console application, helper console application we wrote, and run the query against the production database this time. And we see that the problem is really there. So we get 0 followers every time we ask for it. Only after 10 or so seconds, it converges to the real number. So what happened this time? The problem is that we are treating 0 as two types of data. One of them is 0 followers. The second is there is no value at all. So whenever the database gets slower, the user gets frustrated because the value that he is expecting is not there. How can we solve that? Whenever something like that happens, in functional programming, strongly typed functional programming, we are using data to model everything. So we are using types to model all our assumptions about the API we are writing. So let's change the return type to something more self-explanatory. We know about this option type already, and it models the thing exactly as we wish it to be modeled. So we can have a value. It means that it is in the cache, or there can be non-value. That means it isn't in the cache. So we can then feed back to the user the real state of this functionality, of quantity of his followers. So let's change that. So this is the new snippet. What we need to do is just to turn the return type in line 33 to option integer instead of integer. And not much changed in the implementation. The only difference is line 37. In this case, we just got rid of get or else. And now it only gets the citizen name, we use the hash map from Waiver, the get returns option. And the GUI part, the web application, now can say the loading whenever there is none returned from the server. Now user knows exactly what is happening. So everything works fine, right? One night, the telephone starts ringing, and it's our client again. He's not happy, and he files a bug report. He can't check how many followers OB1 Kenobi has. Okay, so we run to our desk, fire up the computer, the helper console application we have to check the things like that, and run the query against the production database, because why not? And we can see that really OB1 Kenobi has loading followers all the time, even after 10, 20 seconds, always loading. So what happened? Now, we didn't cover the failure case for the future. For each, as I said before, only executes the lambda we provide when the future ends up being successfully completed. So whenever there is a failure in one of those futures, we just don't do anything. We don't update the cache. That's why it is always loading. So our database, of course, is not designed well because it's throwing just exceptions every time there cannot be any user. But you may imagine that we can have also some technical problems like timeouts or something like that, and the same thing would apply. So OB1 Kenobi couldn't be found because, as you probably noticed, OB1 is spelled with capital W, not a small letter. So what can we do? Again, whenever there's a problem like that, in strongly typed functional programming, we use data to model everything. So we use types to model our assumptions about the API. In this case, we use try-type from Waiver. Try-type models the computation that may fail. So whenever the computation fails, it is a failure case, and it conveys the exception. But whenever the computation is successful, it returns the instance of type T that we wanted to compute. So as you can see, there are some similarities between try, option, and future, because the same diagram is being used. So let's modify the return type. Line 44 at the top, we need to first modify the cache type that we had. So far, it was just string to integers. Now it's string to try of integers. And we are changing for each, which only calls our lambda whenever there is a successfully completed future, to onComplete, which is called every time future completes, no matter whether it is failure or success. So now, directly in the return type in line 46, you can see what the API is expecting of you as a client. So option means that the value is there or not, but if it's there, it may be a successfully computed value or some kind of problem, error. The best thing about this new type is that we have two calls to the database, so two potentially failing calls, but only once do we need to handle that failure. So doing all the computation inside the one context of future lets us deal with the problem whenever we need the final value, and in functional programming, it's always at the end. So two calls, one failure handling, and the end. So we changed the API, and the GUI application has also been changed. And now, whenever there is a non-return from the server, we can say that it's loading again. But whenever there is some failure, we can just update our application to handle it gracefully. And it's up to the UX designer to say what does it mean. But let's assume that it's something like that. Now, user knows exactly what's happening, right? OK, so everything works fine. But one night, again, our telephone starts ringing. This time, it's our client again. And he is not happy with our return types. They are so complicated, he says. But suddenly we realize that it's just a nightmare. It wasn't the client. It's just our mind. It's our second thoughts about what we have just implemented. So maybe it's a sign, right? Because whenever there are some problems in the code appearing in our dreams, maybe it's a sign that we should at least think about them. So maybe we should be using some other type. But what about all the assumptions that we want to have in our return types so that the API client is happy about what really is going on under the hood? So we want to eat the cake and have it too. And there is a solution for that. There is a thing called algebraic data types, and we can just have some kind of algebraic data type as our return type, which is simple enough and models everything we need. Algebraic data type is product or sum, so it's just a sum of types or product of other types. Product is just a normal POJO. For example, whenever the class consists of two types, Boolean and int, it's a product type because it's a Boolean and int at once, right? And some type is one type or another type or another type, but none of them can be in one instance together. And of course, those can be mixed together. We have already seen some of those. For example, the citizen is a sum type, because it can be either civilian, Jedi, rebel, Sith, or stormtrooper. And stormtrooper is a normal product type because it consists of the string name and Boolean flag. And of course, try and option also are sums, ADTs, because the option consists of none and sum, and try, success, and failure. So let's model our result return type as ADT. We'd like to do something like that. So remote followers data is the ADT, is the result return type that we'd like to include in our application. And it has 4 different types. So it's a sum type. It can be either not requested yet, it can be loading, it can be failed and convey the error message, or it can be fetched and convey the integer of followers. Now, our function needs to return remote followers data. Looks nicer because we exactly know what the type conveys. But when we think about that, how can the user use that function, right? So the function, this is just a marker interface. This is just a marker interface, remote followers data. So how can anybody use this kind of thing? But before I answer this question, let us think how can we implement this function in the first place? Because we have tried followers in line 80 that are the try of integer, and we want to, based on whether it's a success or failure, we want to create different remote followers data type, right? So if it's a success, we want to create fetched. If it's a failure, we want to create failed. So in functional programming, ADTs go well together with pattern matching. And in Java, using Waiver, you can also do pattern matching. Pattern matching consists of 2 basic blocks. Whenever you have case, you are just decomposing the ADT sum type into branches. And whenever you decompose the sum type, you can just pattern on the product type inside. So in this case, in lines 81 to 84, you can see that we are matching over the tried followers, which is of type try. And whenever it's a success, we just with this $, extract the value from success and call new function on fetched with that. So we are creating new fetched with the integer followers. And whenever the case is failure, we are also extracting the value with the $, and pass it to the constructor of failed. So the whole expression, the whole statement, is a value of remote followers data. We can return just that. So knowing that, we now know how to handle this kind of return type, our own return type, which is remote followers data. So we just pattern match on it in our console application. What we want to do is to have a string that we can print on the console. So we just get the followers in line 46, and then pattern match on remote followers data. Whenever it's not requested, we just put a string, loading, put a string, and when fetched, we extract again with the $ operator or function, and call toString on it. And whenever it's an error message, we just format a new string out of it. And the whole expression, again, is of type string. So both ADTs and pattern matching are built into Scala language. ADTs can be created using sealed traits. Sealed means that all the implementation classes or the case classes that are extending this interface or implementing this interface needs to be defined in one file. So nobody ever can add a new type into our ADT, and that's why sealed is so nice. And the final case class is just a normal POJO with all the hash codes and equals implemented for you. And pattern matching looks very nearly the same as in the Java version, but it's a syntax, not a additional library. So everything works fine, and we have our nice application that's working fine, and one night the telephone starts ringing again. This time it's not our client, it's our user. Turns out that our application is getting popular in the galaxy, and it's starting to be used as propaganda tool. That's not good. Followers count has been used as propaganda tool. So our new user, what he said is that the clones, the Stormtrooper clones, are counted as followers for Darth Vader, and they shouldn't be. By the way, the user is part of a rebellion, of course. So we fire up our computer, of course, and we check in IDE what kind of logic do we have right now in order to count the followers. And it turns out the logic is like that. We are only returning the size of the list. So user is right. It's a bug. So let's first create a function, a small function that only takes a citizen and returns false or true whether this citizen should be counted as follower or not. So how this function should be implemented. So if there is a civilian, it should be counted as follower. The same for Jedi, Rebel, and Sith, but for Stormtroopers, only the ones with the flag is cloned false should be counted as followers. So how can we do that? How can we use the knowledge that we've just learned, which is pattern matching. Of course, pattern matching to the rescue. So let's call a count function on the list in Waver. So what count does, it takes a function as a predicate, whenever the function and runs the function against each element in the list. Whenever the function returns Boolean true, then it is counted, and whenever it's false, it's not counted. So this fits well into our definition. So we pattern match on F, which is just one of the elements in the list, one of the citizens, and whenever it's a Stormtrooper, we just extract the first name, the name value, and we also extract the true. So whenever it matches the true, we return false. And for any other case in line 19, we just return true. So that's the whole implementation of the thing I just described. Almost exactly the same thing can be done in Scala, of course, but a little less verbose, as you may expect. So again, everything works fine, but one night, our telephone starts ringing. And this is our client again. He's not happy, and he files a feature request this time because the application is pretty stable. And so he says that the tweets that the users are posting have gotten some of them gotten rather political. And we went to our computers, fire up the Galactic Twitter, and we can see that some of them are really rather political. But it's our client, and he provided initial list for the censorship module. We need to implement the censorship module, but those tweets cannot just be deleted. They need to be manipulated in a slight way. And the rules are defined by the client. This is just initial list, as he said. It may change. So the rules are like that. First, we get a predicate. So if the tweet is pro-dark side, then we do an action, manipulation action on that tweet. And so on and so forth, but no more than 2 manipulations for one tweet. So we took the naive approach, right? So each rule is a new if block. And yeah, we need to keep an eye on manipulation, so we need to count them in the variable integer, and we go on and on. So one big block of code with mutable variables. So can we do better? What do you think? Can we? So whenever we face a problem like that, in strongly typed functional programming, we use data to model everything. So let's model the censorship algorithms as data. Let's model censorship filters as data. So we need censorship filter which contains two functions. First one is should the tweet be manipulated. Second one, how to manipulate the tweet. So the first is a function from tweet to boolean. Second is from tweet to tweet. So what can we do with such a type? We can create a list, and this is a Java code. We can create a list of all current filters. So those pink ones are the real functions, and we just create new censor filter out of those functions that are defined in some other way, pure functions. But this is just data. This is just a list of some objects which contain function objects. So what we can do with that is we can get an original tweet and just run through the whole list of censor filters. Going through each of the item, we call a function with the tweet, current version of the tweet, and the filter that we are executing right now, and we get a new tweet in return. We do that for every element in the list, and we get a censored tweet as a final value. So this is called folding. And to give you some perspective, let's do it for ints. We have a list of 3 ints, 4, 6, and 3, and initial value is 0, and we just run the 0 through the list, folding it with a function that sums the current result with the element called x. And what we get, we are folding the whole structure, the whole list into final number 13. We can do that in Waver using fold left function. Java Slang collections list has fold left function, and it takes 2 parameters. The first one is the initial value. The second one is by function, which is a function that takes 2 parameters. The first one is the current result, and second one is the element of the list that we are currently processing. And in our case, the apply filter function, the function that we provide for fold left, needs to look like that. It's called apply filter, and it takes tweet, current version of the tweet, and current filter. We just called should manipulate on the tweet and return the manipulated tweet in return. But whenever it shouldn't be manipulated, we should just return the original tweet. So this is how it looks like. Okay, so what we missed so far is that manipulations, right? So we only want to do 2 manipulations to 1 tweet. So what we need to do is we need to create another type, which is called censor status. It has this tweet that we've had so far, but also has integer of manipulations. And what we need to do is we just need to modify slightly our apply filter function. It now takes in line 102 status and filter, and just gets tweet out of the status. And whenever there is a manipulation, we return a new censor status with manipulations incremented. So folding allows us to have state without any mutable variables. Everything here is final. So this is the whole algorithm. When you the meat is over there 96 and 97, we just create initial status with the original tweet and 0 manipulations, and we fold left through the whole censorship list. The cool thing about that is whenever the rebellion is winning or whenever Empire is winning, we can just feature switch on the lists. So we just need to change 1 line of code. We can use rebellion filters, Empire filters, whenever one of them wants some other censorship modules. So we can use just that. Whenever we don't want any censorship, we can just provide an empty list. So again, everything works fine, but one night, again, our telephone starts ringing. Unfortunately, who might that be? This time is Uncle Bob. So you don't have a clean code, he says. And he's a real person, right? So he thinks that remote data, the type that we have, is highly coupled with JSON. Oh, Uncle Bob. Okay, so we fire up the IDE and see that public interface remote data, which is a generic version of remote followers data that we use in the application, is really coupled with the JSON, because all the annotations are there, and they take much more space than the real thing, the real row type that's there for some reason. So what we have here, we have two concerns in this piece of code. So Uncle Bob might be right. So concern number 1 is that we want to represent the state of the database cache, right? That's why we created the remote data type. And the second concern is that we want to serialize that type into JSON so that the web application can consume that. So those are two separate concerns. And we cannot deal with that in Java, unfortunately, but there is a nice pattern which is called type class pattern in functional languages. And on the left, you can see our current implementation. So remote data is annotated with all the JSON annotations. So what it does, it knows about it being a JSON response type. And HTTP server, of course, because it uses this JSON type annotated remote data, it knows about remote data and JSON. And on the right hand side, you can see that type class pattern allows us to decouple those things. So remote data is a pure value. Its only concern is this being a representation of a state of database cache. And type class is a group of types that can be used as JSON. And this group of types, the class is not the class from object-oriented, it's a group of types. And the HTTP server, whenever it needs something of type JSON response, and it has something of type remote data, it uses compiler to fetch something that can convert those things. So we don't have to deal with that in our code. We need to deal with that using some compiler magic. And whenever there is a member of type class JSON response, it compiles fine, but when it's not, we get compiler error. So how does it work in Scala? So again, this is our remote data, pure data type, sealed trait, and 4 implementations, 4 case classes, 4 product types, and pure values, as I said before. And now, this is an Akka HTTP server, so their endpoint is called followers / the string with citizen name, and then the request is get, and whenever the request is get, we can complete it with the list of followers for this citizen name. And I split the line 15 into 2, so there's line 15 and 16 so that you can see the type. The type is remote data, this one nice pure type. So we get this remote data type, and we just return it. Remember, Scala doesn't have return. So this is returning remote followers, and we get a compiler error. Cannot find JSON writer, JSON format for this remote data type. So when we go back to this slide, you can see that this dashed arrow is the compiler searching for an instance of type class or member of type class JSON response for remote data and couldn't find it. So we got a compiler error. What we need to do in some other separate place in the code, so this is not coupled together, we just provide an implementation of remote data JSON, remote data as JSON format. So there's a function that we do pattern match on, and we just provide a JSON for each of those cases, of those product types. And we use, in line 15 to 18, we use d.toJSON. What it does, it searches for this particular loading failed fetched not requested classes as members of JSON format. So this compiler recursively goes through the whole list. And the most important thing, line 13, the highlighted one, is implicit. So we just put this conversion into implicit scope, and that means that compiler can just fetch it whenever it needs it. So this way, this is how the server looks like. There is no JSON at all. This is the final implementation, and there is no JSON at all. We just use the things that we wanted to use. That means the service get followers, service get tweets for, and return them. The compiler will do the conversions for us. So again, instead of subtyping, which is coupling, and instead of annotating, which is also coupling, we can just use type class pattern, and those things can live alone. Okay, everything works fine. Nobody calls us again, and we can finally sleep well. So this was the Pragmatist Guide to Functional Geekery, starring Coffee House programmer, Darth Vader, and Luke Skywalker. Of course, Uncle Bob was also there as a star guest. And special effects by future type, which models values that may be available in the future or failures. Option type that models values that may not be there, and try type that models computations that may fail. Both all three of them can be treated as monads. And algebraic data types that help us model reality because reality is very complex. And pattern matching that helps us deal with ADTs because ADTs may get complex. And type class pattern that helps us decouple the concerns from each other. And the screenplay is by this GitHub Galactic Twitter repository. I encourage you to look because the Java and Scala implementations are there and they have similar functionalities and they do exactly the same things. So you can just look around and see the differences between those two implementations. And there are real web servers in Scala and Java of Akka HTTP, console applications, pattern matching details. So you can see how this is really implemented inside. In Java, there's more code than I shown. And remote data as a functor. So you can see why do we need functor and why remote data can be one. And of course, pimp my type pattern in Scala, which is adding methods to existing types. Please go there, have a look, play around. The README is very nice. I explained all the 6 problems I shown you in the presentation there, and there are in the comments. So that's pretty much all I wanted to show you. My name is Michał. This is my blog. I work at Ocado Technology, and this is my Twitter. Thanks a lot for your attention. And are there any questions? Yes? Yep.
Most probably not the best API available, but many methods, but it's like maybe it's like more convenient.
Okay, so the question is why did I choose to use future, not future from Java slang, not future from Java? So yeah, those guys work together very very well. Option is also there is also optional in Java, right? But they use option from waiver, so they work together very well. And also the Java slang one is a ADT. So it's really implemented as that inside. There are several other differences, and the same for option. For example, option in waiver is serializable, and optional in Java is not. So there are differences like that. But what I wanted to use really is waiver all the way without comparing the Java equivalents. I suppose that you can do both. No problem. Any more questions? Okay. Thank you very much.